Hi everyone, my name is Gabriel Skantze. I am a co-founder and chief scientist at Furhat Robotics. I'm also a professor in speech technology at KTH in Stockholm, Sweden. And I would like to say welcome to this tutorial on conversational interaction with social robots. So in this tutorial, we have three parts. And this first part, which is this video, is an introduction to conversational interaction with social robots. So what is a conversational system and how is a conversational robot different from, for example, a smart speaker or a voice assistant? In the second video, we will give you an overview of the Furhat platform and the SDK. And that will be used specifically for the practical exercises in this tutorial. So that you in the third part can do a practical tutorial where you will be able to create a skill for Furhat using our Blockly tool, which is a graphical programming tool to create basic Furhat skills. But let's start with this introduction to conversational interaction with social robots. So the idea of having a machine that you can have a conversation with has, of course, been around us for a very long time in science fiction. And people have dreamed about this for a very long time. And there are very exciting films that you might have seen, such as 2001 or the movie Her, which are sort of basic speech interfaces. And then, of course, there are these movies with robots in them that we see here also. And it has, of course, always been clear that the way you interact with these robots in these movies is by talking to them. Luke Skywalker wouldn't pick up a remote control to start interacting with C-3PO here, but it's clear that they talk to each other. So that's an obvious application for conversational technology is human-robot interaction. Of course, nowadays we actually have a lot of conversational machines around us, and we find conversational systems in our mobile devices. We find them in cars, where it makes a lot of sense, of course, because you have to keep your eyes on the road and hands on the wheel, so that it makes a lot of sense to talk to the system. There are chatbots, which are mainly written interaction, smart speakers, video games, and then we have social robots, of course. So regardless of what kind of conversational system you have, there are sort of some basic building blocks that you often find, which you can see here in this diagram. So typically, if this is the user and you have your system here, you have the user speaking. So we have speech from the user coming in, and we have a speech recognizer or an ASR, automatic speech recognizer. And the task of this module is to transform this audio into words. So we have a textual representation of what the user says here. The next module in this pipeline is then the natural language understanding that you find here. And the task of that module is to transform this text into a semantic representation, something that the system can use in order to know what the overall intent of the user is. So in this case, if the user says, I would like to nap an apple and a banana, we would like to represent it perhaps some way like this. We want to know that the user wants to order a fruit, and we might want this list of fruits that the user wants. And the task of the natural language understanding is to transform the user's request into the same semantic representation, regardless of how it was expressed. The user might have said, so now I would like an apple and maybe a banana or something like that. And we want the semantic representation to be the same. The dialogue manager's task is then to take this and produce an action for the system, which can often be to say something back to the user. We might have a step here which is called natural language generation, which means that we transform this into a text that will be 10 crowns. And then a speech synthesis component that turns this into audio back to the user. And then we have a dialogue or a conversational system going on in this loop here. Of course, you can remove these two components, the speech recognition and the speech synthesis, and then you have a chatbot where you would type this in to the system instead, and you would read back the response from the system over here. Or you could have only speech recognition, but reading it back and so forth in different variations of this. And for a long time, conversational systems were only, you only interacted with them by typing and reading the response. Mainly because speech recognition didn't work so well for a very long time. And that is maybe something that many people don't understand, why speech recognition has been such a hard task or a hard problem to solve. And there are many reasons for that. One is that we all look different in our anatomy, which means that our speech that comes out will look very different. Between different persons, and also depending on our conditions, if we have a cold or different dialects and so on. But moreover, speech is a complex signal. This is actually what the speech signal looks like, and you might think that, okay, so there might be a word here or a word here or a word here or a word here or something like that. But that's not how it is. You can't easily find words in the speech signal like that. So the same speech signal that you see here, it could actually represent the utterance how to recognize speech. And you can see that the words do not very clearly align here with what you see in the speech signal. And even more, the exact same audio could also be how to recognize speech. And so the question then is, how does the listener know which interpretation to choose? And for that, you need to have an idea of what is a likely thing to say in this context or in general. If we don't know anything about the context, we probably think that the first version here is more likely. But in a given context, maybe the other one would be more likely. So this is a fundamental, very tricky problem to solve for speech recognition. You have to map the audio to words, but you also have to figure out what is likely to say. What is a person likely to say? And it's only in the last decade or so that this has really become a feasible task. This is a graph showing the speech recognition performance. This is the word error rate, so it's the percentage of errors that the system make. And we can see here that if we go back in the 90s, we had a very high error rate, and you can't create a conversational system with this kind of errors. But over the years, there have been steady improvements, and it's especially this dip we see over here, which actually ends in 2015. So there are additional years of improvement here, and that's the impact of deep learning, where we have new techniques for actually doing speech recognition that turn this technology into something useful. So nowadays, it's not always the speech recognition which is the problem and challenge. It's actually the other components of the system, which is illustrated here. So the NLU, or the natural language understanding that we mentioned before, can often be the problem. So here are some fun examples in interaction with Siri. So what can I help you with? Siri, I'm bleeding really bad. Can you call me an ambulance? From now on, I'll call you an ambulance. Okay. Or I think I have an alcohol poisoning. What do? I found 7 liquor stores fairly close to you. So in both of these examples, we see that the actual speech recognition probably worked 100%, but that the understanding of the user's intent behind this failed in these cases. So there are many different components or sort of steps in this process that can potentially fail and cause misunderstanding. So that's sort of a basic technology that is sort of same for all conversational systems, regardless of whether it's a smart speaker or it's a social robot. But then you might ask yourself, what is really the difference here? Why why do we want a social robot like this when we can equally well interact with our smart phone or voice assistant in a smart phone or a smart speaker? What does this really add? And one way of addressing this is to compare it with with communication between two humans. So why would we ever want to meet in person when we can equally well just call each other over the phone? And then it's perhaps clear to everyone that you do prefer this way of interacting. And there are many reasons for that. Of course, you can see each other, so you can see each other's faces, but you can very quickly take a glance at the other people in the interaction and see whether they are following along, if they understand what is being said, understand if people are falling asleep, or who is attending whom, and do people seem to understand that they are being addressed, and so on. And that's very hard to do in a phone conversation, or even if you have especially if we have a multi-party interaction, for example, in a remote meeting over Zoom or something. This can be very problematic, but it's so much easier when we meet face to face. And we can also have things placed on the table so that we can point to these objects and look at them at the same time and attend to them. So if we make then the analogy here to the interaction between a human or humans and machines, we see that it's sort of similar here. If we have a robot, we can very easily read each other's reactions, and we can point to things on a shared space and so on. There's also not only these kind of practical issues when it's multi-party interaction, but there is also this notion of presence. So having someone present in the same room is somehow different from interacting with them remotely. And this has been found in experiments like this, where they compared, this was a learning task where you have to learn a specific task, and you have this little tutor. And even if it's a very sort of basic character here, this little bird, if you have the bird physically in your same room, you actually learn the task faster than if the bird is presented on a screen. So that's very interesting. And this is because of this physical presence. If we look at the face then, what does a face add to the conversation? We can see that, think of it both from an output perspective. So if the machine has a face, like in the picture here, a robot face, we can easily see that where the agent is attending. So we can see whether it's looking at me or it's looking somewhere else in the room. I can read the facial expressions of the agent. I can read the lip movements of the agent, so that helps me to hear what the agent is saying. And I can see if the agent looks happy or confused, for example. So it's a lot of information there in the face. From the input side, if the agent has a camera, it can, of course, more easily detect if there is someone who wants to interact with the system. It can potentially recognize people more easily and read their facial expressions if they look happy, for example, and also read their intention. So, for example, we can see whether this person here is looking at the agent and interacting with the agent, or if they are looking to each other and trying to interact with each other. So there is a lot of information there in this face, which can often be quite subtle also. So if we look at attempts to sort of give machines a face, we can see different examples here. This is the Now robot, and we can see this is quite a typical design of robot faces, and you can see it's very unexpressive. It doesn't have any lip movements and no facial expressions. You can to some extent see the gaze direction of the robot, but it's quite limited because you can't move the eyes independent of the head. You can of course do more abstract representation like this, which can be very expressive, but an argument for having a more human-like face is that we already know how to interpret these signals. We know what a raising of the eyebrows typically mean or a smile. Of course, you can do this kind of very human-like faces, but then these can be very costly. They can also be a little bit uncanny. If the appearance is very human-like, but you cannot really match that with a human-like motion and movement of the face. Then, of course, there are animated agents on displays like this one here. And they can be very expressive and have subtle movements, and we often don't find these very uncanny. But the problem is that they are presented on a flat display, so it's a little bit back to the Zoom or the Skype conversation, the feeling that you're having that kind of interaction with the agent rather than this interaction where you are present in the same room. And this has a practical effect that is quite interesting called the Mona Lisa effect. And we can see here, we have this is actually a concept video from when this Microsoft Kinect was released. And we can see here how it's sort of staged so that from your perspective, it looks like they have eye contact here. And in reality, from this person's perspective, the agent looks like this. So the agent doesn't look at her from her perspective. And this is the problem of presenting 3D agents on 2D displays. So for this agent to look at her, it would need to look straight into the camera. But then from our perspective over here, it wouldn't have looked like it was looking at her. It would have looked like it's looking at us. So this is very good if you have a news reader on TV and you have people spread out in a living room, because it looks like the news reader is looking at all of them. But it's a problem if it's an interactive agent, because you want the interactive agent to look at one specific person and be able to address one specific person. And that's not really possible with agents on flat displays. So this was the reason why we at KTH developed Furhat, which is a animated agent back projected on a 3D mask that you can see here, very early prototypes, and later on here you can see the latest version of this robot. So Furhat Robotics is a spin-off company from KTH, which is producing Furhat, both the hardware and the software platform that you will be experimenting with in this tutorial. One of the advantages of having this kind of animation is that you can actually animate and project many different types of faces on this. It can be human-like or less human-like. It can be more cartoonish or less cartoonish. It can be a man or female or an adult or a child, or even a non-human creature like this. So it's very flexible for doing studies or research on the impact this might have on the interaction, or simply because you want different personas. Another advantage of this animated face that I just touched upon very briefly is the lip reading. So you can do experiments, which we have done in research, on speech perception. If you deteriorate the speech, if you add noise to it, you can see how many words people still recognize by being able to read on the lips. And now I'm not talking about hearing impaired persons. I'm talking about persons who are not sort of used to reading on lips. But the fact is that we all do read lips to improve our speech perception. So in this case, we had, if you add enough noise, only for 44% of the words could be heard by the subjects. And by having this mechatronic robot doing lip movements, it didn't improve the speech perception. But adding this kind of animated agent clearly improved the percentage of words that you could hear. And of course, looking at the actual person speaking is even better, of course. but it's a clear improvement here, and it shows that also the lip movements of the agent are important for speech comprehension. So compared to a normal conversational system, or sort of a system that is speech only, of course, having a social robot with a face also adds things that the system needs to be able to do. So what we call this is situation awareness. In the case of the robot, of a smart speaker or a speech-only system, it only needs to pick up the speech from the user. But here we have to have cameras and microphones to be able to understand what the situation looks like. So we pick up this using sensors, and then we have to figure out. So this is a 3D reconstruction scene from the above of the interaction, what the interaction looks like. And we have the two users here interacting, playing this card game that you can see over here. And you have the table here with objects on the table, and you have the robot here, and we can sort of estimate where these users are looking also, which helps us to understand, for example, turn taking. Are people talking to each other, or are they addressing the robot? It also helps us to direct the robot's neck and face and gaze, so that we can get this kind of eye contact between the robot and the user. So this means that if we compare, we looked at this before. We have a user here. We have speech recognition, natural language understanding, dialogue management, natural language generation, speech synthesis, and then back to the user through this robot here. But in the case of a social robot, of course, we need a lot of other components. So we need to be able to have a camera so we can detect faces. We need to model the situation, as I just mentioned. And we also need to control the attention of the agent by rotating the neck, by using facial animation, so we can direct the eye movements and so on. And of course, the speech output has to be synchronized with the lip movements of the agent. So clearly, this is more sort of creates a more complex architecture for this kind of system. Another different from a spoken speech-only interaction is that you have much more things going on at the same time, since it's sort of a multimodal system. And in a speech-only interaction, first the user says something, and then the robot answers, and then the user says something, and so on. But if we look at the timeline of a more multimodal system like this, we could, for example, see here, we have the different components over here, and this is the timeline. We might have a user appearing in front of the camera, which makes Furhat look up at the user, and say, hello there, and then listen for a speech, which in turn makes the robot raise the eyebrows. The user might be moving around in front of it, which means that we should shift the gaze around in order to maintain eye contact. We might detect that the user says hi, and we might want to smile in order to acknowledge that, while at the same time we want to say, how can I help you? But now the user is perhaps leaving in the middle of this, so we have to change and say goodbye and look down again. So you can see how things happen all the time, and it is not this kind of one turn at a time, but it's more of a continuous updating of different things that happen. And we typically do this, in Furhat at least, by sending various forms of different events of things that the robot is sensing, and actions that the robot performs, and monitoring its own action to know when things have been executed. So that can, for example, trigger other things that should happen in the platform. So now I want to show you a video of what an interaction looks like with Furhat. And you can see this situation model over here that I talked about before. And with the two users and their direction of looking, and the robot here, you can see what the robot looks like here during the interaction and what the robot does. and you can see the camera feed here. It's all in Swedish, but it's subtitled in English. And the idea here is that there is a game that these two people play. It's actually me and my colleague. And we play this game where we are supposed to sort these cards on the table according to a criterion. So in this case, we are supposed to sort these countries based on how many gold medals in the Olympics they have. And you get a little bit idea of this idea of that things happen all the time, and the robot has to figure out when it's supposed to speak and not to speak, and where it's supposed to be looking, and so on. So these can be things that is a little bit interesting to consider while looking at the video.
Jag har hört att Italien har många guld i fäktning och cykling.
Ja, men de är väl ganska bra, är de inte det? Kanske ska ligga med här borta. Kanske.
Ja, jag vet inte.
Danmark vet jag inte hur bra de är.
Kanske med vintersport, men alla andra länder, Portugal, Italien, de är inte så bra med vintersport.
Nej.
Grekland.
Men Finland har väl mycket. Är inte Finland bra på vintersport? Vad tror du?
Finland har ju mycket snö. Så de borde vara bra på vintersport.
Ja, jag tycker också det. Vi lägger dem ganska högt här borta. Men kanske inte lika högt som Italien. Danmark kanske.
Jag tycker också att det verkar bättre att ha Finland där.
Ja, det tycker jag också.
Jag tycker att det verkar rimligt att Finland har färre medaljer än Italien. Vad tror ni?
Färre, alltså fler, mindre. Vad tror du om Grekland och Portugal då?
Jag tror att Portugal har ganska få medaljer. Det kortet borde kanske ligga längst här borta.
Ja, kanske. Tror du att de har färre än Grekland?
Kanske. Ja, jag kan inte se.
Nu tycker jag det ser lite bättre ut.
Ja. Men vad tror du? Är vi klara sådär eller?
Ja, vi kan.
Okej. Är det här vår slutgiltiga gissning?
Ja, det tror jag. Vi kollar. Ja.
Wow! Alla rätt.
Ja.
Jag trodde att Grekland har fler medaljer än Danmark. Men det var fel.
Ja, det var tur att vi inte
nu
lyssnade
har ni
på dig.
spelat 2 omgångar. Kanske det finns andra som vill prova.
Kanske. Tack så mycket för det. Tack.
Okay, so what you can see here is clearly that it's not only someone asking a question and getting a response that we're used to see in interaction with voice assistants, but it's actually an ongoing conversation here where it's sort of more open to take the turns, and we also have 2 users interacting with the robot, so it makes it also more challenging for the robot to know when to speak and not to speak in this interaction. So another way of describing this difference of interaction with traditional voice interfaces and more social agents like a social robot is that it's sort of different metaphors for the user. So in the case of a voice assistant, you might want to have a more neutral personality that is basically just answering your question or performing your commands, whereas in the other extreme you might want to have more of an agent that has a personality and maybe it's emotional. In the case of a voice assistant, it might be more reactive. It does what you tell it to do, whereas in the case of this kind of more social entity, it might have more agency. It might be more reactive and proactive and suggest things to you. The kind of things that happen in the interaction in the case of a voice assistant, if more of a question answering and maybe command and control, whereas in the other case, it's more of engagement and maybe negotiation. Context might be less important in this case. You ask a question and maybe the immediate preceding context is important, but here in this case, context is very important, not just the context we mean like what is the previous interaction and also the surrounding context and things happening. Like the example with the game here, what is happening in the game board and so on. And that's also in the case of a voice assistant, you might have a graphical user interface which provides the same kind of information that the agent provides. But in the case here, the graphical user interface is, which is the table here, is sort of not part of the agent, but it's something that we discuss together with the agents. So that clearly creates different metaphors for the user and also enables different forms of interaction. So I also want to show you some concept videos that from Furhat or using Furhat. So these are not real user interaction, but it's more to show potential application areas of social robots that can maybe stimulate your imagination.
你能告诉我哪里可以买火车票吗？
你可以去位于你右侧的售票机那里买票。
啊，谢谢。
不客气。
El tren para la capital, ¿en dónde está? Mira, que lo necesito llegar, pero ya. Llevo tiempo buscando y todo eso. Yo no entiendo lo que quieres decir ahí, por favor.
Lo tiene a su derecha, en el andén 3. No se preocupe, tardará 2 minutos en llegar. El tren sale dentro de 6 minutos.
Ay, qué bien, ¿eh? Muchísimas gracias.
So, why should we hire you?
Well, I think I'm the perfect candidate for the role. I love analyzing and organizing and executing these kind of complex projects.
I'm sorry, but I don't believe that you're the person we're looking for.
4 years experience in delivering projects, and the majority of them on time and within budgetary estimates.
Well, you have all the qualifications and experience for this role. It seems like you're the perfect candidate.
Really? Thank you.
You're welcome. It's my pleasure, Nadia.
Okay, ma'am. And what seems to be the problem with them?
Your idiotic manager over there, he told me that these shoes were comfortable. Well, they're not. These shoes are dreadful.
You did really well, Angela. But you can't tell the customers that they're unreasonable.
Okay.
No. So try not to lose your cool next time, okay?
Yeah.
Yeah. Okay, Furhat, let's try another scenario.
Okay.
Let's do the one where the customer has a stolen credit card.
You got it.
Okay?
What do you mean this credit card is not working? Join us in creating a world where technology is more human.
So some of these use cases have actually been tried out. So this is one example. It was a collaboration between Furhat and Deutsche Bahn, where we had Furhat at the Berlin train station and the Frankfurt airport and the Tokyo train station, answering questions that you likely might have at a train station or an airport. And of course, the idea here is also that there are many benefits of having this kind of agent. One is that the agent can switch languages. So in this case, it could speak both German and English and Spanish. And this is naturally an environment where many people with speaking different languages typically might want to ask for information. And also it's situated, so the robot could, for example, look in the direction that it's talking about, and so on. And having a robot like this in a public space creates sort of a very intuitive, natural place where you can go and ask questions just like you would do with a human. And if you are in a hurry, for example, it might be more intuitive to talk to an agent that looks like a human than, for example, a touch screen where you have to understand that specific interface. When it comes to the job interview that you saw in the video, Furhat's collaboration with a company called TNG, a recruitment company, which has now created the robot Tengai, which is a robot that performs job interviews, or at least early stage job interviews. And the idea with this is that the robot should perform the interview in the same way with every candidate to sort of reduce bias in the interview process, because we know that humans have a lot of bias, and humans are very quickly influenced by their initial idea about the person they're talking to, and that will influence the way the interview is performed. Whereas with a robot, you can make sure that the interview is performed in the same way with every candidate. Another example is where we try to use the agent to sort of simulate a person. In the video, we saw a robot simulating an angry customer. This is another example from Robert Johansson, who is developing the robot to be used as a virtual patient for people who study to become psychotherapists. This is a very interesting use case, of course, because here the facial expressions and the emotions and so on becomes very important. So let's have a look at that.
So what problem can I help you with today?
Well, I don't recognize myself lately.
Can you be more specific?
Yeah.
Could you please be more specific?
Maybe there are some problems at work.
That's a bit vague.
Sure.
What happens at work that becomes a problem for you?
I get into lots of conflicts.
Hmm. Do you have an example?
I would say it's more a general problem.
General problem is a vague description, and as long as this remains vague for us, we won't get a clear picture of your problem.
Yeah. Yeah.
So what problem?
So that concludes our first session in this tutorial. To give you kind of an overview and a brief introduction to conversational interaction with social robots, and try to get you to understand how that is different from conversational interaction with things like voice assistants in smart speakers, for example. In the next video, we will look at the Furhat platform, more specifically how you can use that to create conversational interactions so that you finally can try out a little bit on your own. If you have any questions, please don't hesitate to get in contact with us. Thank you very much.